Humans have long looked up at the stars and wondered, are we alone? Among all the planets in our solar system, Mars has captured our imaginations the most. It's our closest neighbor, and it holds the tantalizing possibility of life. While we haven't found aliens yet, the evidence suggests that Mars might have been suitable for life long ago. Mars is called the red planet for a reason. Its surface is covered in iron oxide or rust, giving it its distinctive reddish hue. Billions of years ago, it was much warmer and wetter. Evidence suggests that rivers, lakes, and maybe even oceans once existed on Mars. Over time, Mars lost much of its atmosphere, causing the planet to cool and dry out. The liquid water either froze underground or escaped into space. Even though Mars is a harsh environment today, the possibility of finding evidence of past life or even present-day microbial life is too exciting to ignore. The search for life on Mars is a search for answers to some of the biggest questions we can ask about ourselves and our place in the universe. Today, Mars is a cold and dry desert, but evidence suggests it was once a very different place. Billions of years ago, Mars had a thicker atmosphere, trapping more heat from the sun. This made the planet much warmer than it is today. The evidence for this warmer, wetter past is written all over the Martian surface. We see dry riverbeds, ancient lake basins, and even signs of ancient coastlines. These features tell us that liquid water once flowed on Mars. One of the most compelling pieces of evidence for past water on Mars is the presence of minerals that form in the presence of water. These minerals have been found by rovers exploring the Martian surface. While the surface of Mars is now too cold and dry for liquid water to exist for long, scientists believe that some water ice might still be present beneath the surface. This ice could be a valuable resource for future human missions to Mars. Since the 1960s, scientists have been sending robotic explorers to Mars. These missions have revolutionized our understanding of the red planet. One of the earliest missions to Mars was the Viking program in the 1970s. 2 Viking landers touched down on the Martian surface and conducted the first experiments designed to search for signs of life. While the results were inconclusive, they paved the way for future missions. In the early 2000s, the twin rovers Spirit and Opportunity captured the world's attention with their explorations of the Martian surface. More recently, the Curiosity rover and the Perseverance rover have been exploring different regions of Mars, searching for signs of ancient life and collecting samples for future return to Earth. Perseverance even carried a small helicopter called Ingenuity, which made history as the first aircraft to fly on another planet. These missions have shown us that Mars is a complex and fascinating world. Water is essential for life as we know it. That's why the search for water is at the heart of our quest to find life on Mars. While liquid water is scarce on the surface today, there are still places where it might exist. One possibility is that water ice is hidden beneath the Martian surface. This ice could be melted by geothermal heat from the planet's interior, creating underground reservoirs of liquid water. These reservoirs could potentially harbor microbial life. Another place to look for water is at the Martian poles. The polar caps contain large amounts of water ice, and there's evidence that some of this ice might melt seasonally, creating small, temporary flows of liquid water. The search for water on Mars is a challenging one, but it's a crucial step in our efforts to understand the planet's history and its potential to support life. One of the most intriguing discoveries in recent years has been the detection of methane in the Martian atmosphere. Methane is a gas that can be produced by both geological and biological processes. On Earth, the vast majority of methane in the atmosphere is produced by living organisms. However, methane can also be produced by geological processes, such as volcanic activity or the reaction of certain rocks with water. Scientists are still working to determine the source of the Martian methane. The search for life on Mars is far from over. Future missions will continue to explore the red planet in even greater detail, searching for signs of past or present life and paving the way for human exploration. One of the most ambitious goals is to return samples of Martian rock and soil to Earth. These samples could be analyzed in laboratories around the world, giving us a much more complete understanding of the planet's geology, chemistry, and potential for life. Looking further ahead, there are plans to send humans to Mars in the coming decades. Human explorers would be able to conduct much more complex scientific research than robots and could explore the Martian surface in ways that are currently impossible. The journey to Mars is a long and challenging one, but the rewards are immeasurable. Finding evidence of life on another planet would be one of the most profound discoveries in human history.